Hello friends, how are you? In yesterday class we discussed about the laws of chemical combination. That was law of conservation of mass and second was law of constant proportion. And after that we discussed about the Dalton's atomic theory. Okay. Now in today's class I am discussing about the properties of atom. Properties of atom. The first question which comes in our mind, because it may be possible that some of the students didn't watch the previous class. So what is an atom? What is an atom? The smallest particle of any substance. The smallest particle of any substance. Smallest particle of any substance which takes part in chemical reaction is known as atom. Or we can say that the smallest particle of any substance which cannot further divide is known as atom. But let me clear you, the smallest particle of any substance which cannot further divide, this definition has lots of issues, because in modern time it is find out that atom is also divisible matter. It divide into subatomic particles, electron, proton, neutron. So that's why, as per me, the first definition, which was the smallest particle of any chemical of any substance which takes part in chemical reaction, is better. Okay. Now let me start our topic, that is size of atom. Atom is a very small structure. Atoms are very small. These are highly microscopic is not a good word, that are electron microscopic structures. We cannot see in them by naked eyes. Then the questions come in our mind that how can we define the size of an atom? Since atom is a spherical structure, atom is a spherical structure, and you know that for the spherical structure, if you consider their volume or structure, their size, then the formula is 4 upon 3 pi r cube. R is radius. Other than 4, 3, pi, that are constants. So we can say that directly that the size is depend on the radius. The same point is selected here. Atom is a spherical structure. Atom is a spherical structure. So atomic radius is refers atomic size. Atomic radius refers to atomic size. Now the questions comes in our mind, what is atomic size? Atomic radius. The distance between nucleus and the outermost shell, and the distance between nucleus and outermost shell of an atom is called atomic radius. Now one more questions come in our mind, that what is what is the outermost shell? Atom is just like a onion which has multiple layers. Similarly, in atom, electrons are distributed in the circular paths which are known as orbitals or shells. We will discuss about that in our topic with the atomic structure, in which we discussed about it. Okay, so comes on the topic again, that atom is a spherical structure and atomic radius refers to its atomic size. Atomic, since atom is a very small structure, so its size is measured in nanometer or picometer. In nanometer or picometer. What is nanometer? Nanometer, nm, that is 1 upon 10 to the power 9. 1 upon 10 to the power 9, or we can say that 10 to the power minus 9 meter is known as nanometer. Second one is picometer, 1 upon 10 to the power 12, that is, or that is 10 to the power minus 12 meter is 1 picometer. These two units are used to describe the atomic radius. For example, atomic radius of hydrogen is 120 picometer, or if we consider in simply in meter, then it is 10 to the power minus 10 meter. Here the exact value is not that, it is 0.12, but for the simplification we consider is 10 to the power minus 10 meter. Okay, now the next topic is symbols of atom of elements. The question comes in, that is, what is the symbol? The chemical names of the elements are represented by the symbols. The chemical names of element are represented by the symbols. So we can say that symbols are the shorthand representation of elements. Shorthand representation of elements. Okay. Now, what are the symbols of an atom or element, or how can we decide that? The first concept of symbols was given by Dalton. So we can say that Dalton was the first scientist who used symbols to represent a definite quantity of element, that is one atom of that element. Dalton described or represented the a definite quantity. Here a definite quantity, that means one atom. He used some pictures, which was the first or we can say the initial attempt of symbolizing the elements. Here he showed different atoms, atoms of elements by the circles. That one circle dot, that is hydrogen, dark circle for carbon, simple circle, impeded circle for the oxygen, that one for phosphorus, that one for sulfur, that for carbon, iron, lead, sulfur, platina, mercury and gold. So he used that kind of, but that system was not scientific, or it was very inconvenient or difficult for us. Therefore, one more scientist, that is Berzelius, that is Berzelius developed a new system, developed a new systems of symbols of element, in which one or two letters of the name of the element was used. One or two letters of the name of the elements were used. Now in present time, IUPAC, International Union of Pure and Applied Chemistry, IUPAC approves the name and symbols of element. IUPAC accepted the Berzelius concept. IUPAC accept the Berzelius concept of one or two letters. Okay. Now, symbols of some element found. Symbols of some element. Here, some of the elements are represented by one letter of his name. For example, hydrogen H, because oxygen O, iodine I, carbon C, nitrogen N, phosphorus P, boron B, fluorine F, sulfur S. These are the some examples of element whose symbol is made up by one of the letter of their names. Okay, but as you know, there are 118 elements, and in English that is only 26 alphabets. So definitely two or more, uh, sometimes 5 6 also, elements have similar initial letters. To overcome this problem, to overcome this problem, the two letters concept is adopted, in which two letters, in which out of which the first letter is the first alphabet of name, and second, maybe the second one, maybe the third one, maybe the fourth one. It depends on that where how much the similarity is between the elements. So if two if there are many elements having the first letter same, then two letters, that is first, second, or first, third, are used. But if there is two letters name, then the one rule which is very important, that the first letter is always capital and the second letter is small. First one is always capital and second one is always small. Got it? For example, beryllium, be, barium, ba, bismuth, bi, bromine, br. All of these started from the B. So here first second letters are selected. Now similar example with the C. C is allotted for the carbon as we discussed. Now the other elements like the calcium, cobalt, chlorine, chromium, that these elements also started by the C. To overcome this problem, two letters selected, in which first second, first second, first third is used. So because of the first second, the sign of the calcium becomes, symbol of the calcium becomes Ca, cobalt Co, chromium chlorine Cl, and chromium, that is Cr. Similarly with that, aluminium and argon both started by the A. So two letters are used, in which aluminium represented by Al and argon by Ar. Similarly, magnesium and manganese both started by M, and second letter is also common. That's why the first and third letter here selected. Magnesium Mg, manganese first M, third is N, Mn. So symbol of the magnesium becomes Mg and symbol of manganese becomes Mn. Now some of the elements and their symbols are derived from their Latin or Greek names, or we can say that symbols of some element are taken from their Latin Greek names. For example, sodium, in Latin language it is called natrium, so its symbol becomes Na. Silver, in Latin language it is argentum, so its symbol becomes Ag. Potassium, that is calcium. Here one thing, let me clear you, its spelling is CALLIUM also, and in some of the books that is in some of the book that is KALLIUM, and in some of the book that is KALIUM. Okay, so let me clear you about that. Again, potassium, that is calcium, symbol becomes K. Similarly, iron, ferrum, Fe, gold, aurum, Au, copper, cuprum, Cu. In this concept, one more point is included, that as the name and symbols of elements were also derived from their properties or from the place where they discovered. For example, gold is named aurum because aurum, a similar word, means yellow, and you know that gold is yellow. Okay, and copper, that was first find out in the that is Cyprus, that's why its name becomes that. Now next topic is atomic mass or atomic weight. Atomic mass or atomic weight, according to Dalton's atomic theory, each element has specific atomic masses. Each element has specific atomic masses. Scientists attempt to measure the atomic masses of an element by using the laws of chemical combinations. But as you know, atom is a very small structure. So the physical weighing, that means we weight the other objects like 1 kilogram sugar, 2 kilogram sugar, etc. That kind of measurement with weighing of atom is not possible because it is a very difficult task. Therefore, a relative atomic mass concept was determined or derived. Now, atomic mass measured in atomic mass unit, which is AMU, or unified mass unit U. Modern time we use unified mass to represent the atomic mass. So, or we can say that atomic mass unit AMU or unified mass U considered measurement of atomic masses, that means unit of atomic masses. Now, the question which is striking in your mind, that is, what is relative atomic masses? What is relative atomic masses? Okay, you can understand by taking this example, that is the rubber. Suppose I do not have any weighing concept about that, right? How can I weigh? How can I weight it? Measure its weight. In that condition, we can use relative atomic masses. Arbitrarily, or as my mindset, I decided that this pencil is 5 gram. This pencil is 5 gram. Now, if I measured that this rubber is how much time heavier, from this pencil, then I can decide its weight. Similar thing you observed in the market. When you go for the purchase any object, then you said that give me that 1 kilogram. Then what the shopkeeper did, he put 1 kilogram in the weighing machines one side and start to filling our object, and as the weight increase, and finally where the both comes in equilibrium, that means both the weight rise up and object down, and when they becomes equal, then the shopkeeper stopped and gave us item. That was a relative weight. That was a relative weight. Okay, now we discussed about that what is a relative concept. Now the questions come in our mind, that which thing we can select as a atomic mass unit or as a relative weight. Initially hydrogen is taken as the unit, but after that 1 upon 16 1 upon 16 of mass of atom of oxygen taken as the unit of measurement, then the questions comes in our mind, that why the oxygen selected? Because oxygen react with the large number of elements and make compound. It react with large number of elements and make compound. And second thing, it give mass of elements as whole number, complete number, that is 1 2 3 4 5, or sometime it is fraction, then that is near to a whole number, like 2.9, 2.95, like that. To convert them into whole number was easier process. That's why oxygen is taken as was taken as standard unit of weight. But later on, oxygen also gives some problems in weighing the object, weighing the atom. In 1961, IUPAC accepted as C12 as standard mass unit. That means in modern time we use C12 atom as standard mass unit. According to IUPAC concepts of atomic mass, they said that one atomic mass unit or 1 U is equal to the 1 upon 12th of the C12 atom. Yeah, or we can say that 1 AMU or 1 U is equals to 1 upon 12th of C12 mass of C12 atom. So hydrogen's 1 upon 12th now considered as standard unit to measure the mass, and the masses of other elements is derived, or we can say that is measured by using the 1 upon 12th of C12 atom. That means we can say that now 1 upon 12th of C12 atom is selected as standard reference unit. That means with the help of that we derive the atomic masses of other elements. So we can say that the relative atomic masses of all elements measured with the respect of 1 upon 12th of C12. Now the questions come in our mind, that is how can we do that? Now after deciding the unit of atomic mass, the relative atomic mass of element can easily calculate. Now we have to find out that the object is how much time heavier than 1 upon 12th of C12. 1 upon 12th of C12 is 1 U. If an object is 10 times heavier, then its weight will be 10 U. If an object is 12 time, then its weight becomes its weight will be 12. Relative weight or relative mass will be 12. Okay, so we can say that relative atomic mass of the C12 of an atom is average masses of the atom or compared to 1 upon 12 of masses of C12. Or we can also say that relative atomic mass or atomic mass is the number which indicates that an atom is how many times heavier than 1 upon 12 of mass of C12. That's why if we make it formula, then we can say that relative atomic mass is equals to mass of an atom of element divided by 1 upon 12th of mass of C12. If an atom 3 times heavier, then here the answer is 3. That means its relative atomic mass is 3 unit. Some of the relative atomic masses, or simply we can say that atomic masses are hydrogen 1, carbon 12, nitrogen 14, oxygen 16, sodium 23, calcium 40, chlorine 35.5. Okay, and let me clear you that you have to memorize these atomic masses because they are very important for our calculations. Okay, now let me move to the next one, that is molecule. What is molecule? A molecule is the group of two or more. A molecule is the group of two or more atoms that are chemically bonded with each other. A molecule is the group of two or more atoms that are chemically bonded with each other. Or we can also say that was on chemical composition, and that is it on the basis of its existence. So the second definition of molecule is the smallest particle of any substance or any element or compound. We can say that any element or compound, or we can say any substance which freely exists in nature, and shows the properties of that element or compound or that substance. Depend on us that which word we are using here. Okay, so molecule is the smallest particle of any element or compound which freely exists in nature and shows all the properties of that substance. Got it? For example, H2O. Here one is hydrogen and one is oxygen. that is group of atom HCl, ZNO, CaCl2, NH3, etc. come in the category of atomic, comes in the category of molecules. Now, on the basis of the chemical composition, molecules are two types. First is molecule of element and second is molecule of compound. Now, we discuss about that molecules of element. Molecules of similar or one type of atom is known as element, or we can say that a group of similar type of atoms is known as element. For example, H2, both are hydrogen atoms, O2, Cl2. Okay. Now the one more important thing about the element is atomicity. What is atomicity? The number of atoms, the number of atoms present in an element, molecule of an element, is known as its atomicity. Is known as its atomicity. We can say that the number of atoms present in a molecule of element is known as its atomicity. On the basis of atomicity, elements are grouped into monoatomic, diatomic, triatomic, tetraatomic, penta, hexa, polyatomic. Okay, very simply you can memorize it. Mono means one, atomic means atom. That means elements which are made up by only one atom. There is no group of atom, that is only one atom. For example, noble gases like helium, neon, argon, krypton, all of these gases freely exist in nature. That means single atoms are found. Now diatomic, as the name indicating, elements which are made up by two atoms, that is diatomic, like O2, two atoms, Cl2, two atoms, hydrogen gas H2, nitrogen gas N2. Both all of these examples have two atoms, so that is diatomic. Similarly, triatomic, three atoms, like the ozone, that is O3, comes in the category of triatomic. Similar like tetra, penta, hexa, hepta, and so on. Okay, about the molecule of compound we will discuss in next video. Thank you, hope you enjoyed and like it.